Sorry, the mic is not working, so me and Professor Hand has to speak out loud today. And I'm talking on behalf of the ASAP group. We are really honored to have Professor Kim Hand here. And I think I don't need to give so much introduction given the long-standing work of Professor Hand in the cell cycle field. And it's very interesting when you go through his biography how this started from hemoglobin gene protein synthesis, going through some work on sea urchin and finding out that cyclins are actually regulated through the cell cycle. And this led to the Nobel Prize assignment together with Hartwell and Paul Nurse in 2001 about the discovery of key regulators of cell cycles like cyclins and CDK, right? So I'm not going on. That tells you I'm not an expert in cell cycles. So I let Professor Hand speaking, and thanks a lot for coming here.
So I hope you can hear me at the back. There's no artificial aids here, apparently. Well, it's amazing, isn't it? I mean, you know, whenever they build a new lecture theatre, I've never known a lecture theatre be built where they just had a simple light switch which sort of had on and off. You know, they all make bloody touch screens and fancy stuff, you know, because they call in audio-visual experts who've never given a lecture in their lives, and who love it to make it complicated. I like it simple. Anyway, so I guess these are, I like, when I get bored in airplanes, I start taking photographs. And, you know, I sort of realize I don't really understand what a wave actually is, but there's lots of pretty waves, and why do they, you know, why do they curve like that? Life is full of mysteries. So I'm going to talk about some recent work that was done by just one postdoc in the lab, and I should explain that my lab doesn't really exist anymore because I'm going to turn into a pumpkin on December the 1st, which is great. It's quite funny, this retirement business. You know, some people like to go on and on forever, and other people like to quit when they've had enough. I'm in the latter category. In fact, it was very funny. My wife was sitting next to Fred Sanger on the way out to in 2001, on the way out to the Nobel celebrations. They invited everybody. All living laureates were invited back, so some of them couldn't make it because they were too old and infirm. But Fred went, and my wife introduced herself to him. And he said, oh, you know, I was so glad when I could retire, he said, which he did. It was absolutely amazing. Fred was in the lab working away on the day before his 65th birthday. On the day of his 65th birthday, the lab was completely cleaned out and there was no sign of Fred. It was amazing. So he said, you know, it was so great. I couldn't wait to retire, he said, because it was so hard. Isn't that amazing? I mean, here's a man who solved the structure of proteins and the structure of RNA and the structure of DNA, 2 Nobel Prizes, incredibly modest, but it was just so hard. And it is. But it also isn't. It's tremendous fun. So this, I'm going to tell you about what I think is a very interesting new development, which you won't read about in any of the textbooks, an absolutely essential component, or actually set of components which are necessary for entering mitosis and for staying in mitosis. And the reason they're not in any of the textbooks, I think, is because they don't exist, or they don't do the same thing in yeast. So watch out. Although it's true that yeast mostly does what we do, there are exceptions, I think. And well, we'll see if you believe it. So basically we're talking about one cell becoming 2 cells, and as you know, that's mostly about duplicating the chromosomes is the most important thing, but lots of other things have to get duplicated as well. So this is rather a complicated business, one cell